Algebra 2, Chapter 8.1, Finding Rational Solutions of Polynomial Equations. We'll go over some things, including the rational roots theorem. Essential question, how do you find the rational roots of the polynomial equation? And so we are looking at specifically here for the standards of degrees 3 and 4 using algebraic methods. So let's go on here. Explore relating zeros and coefficients of polynomial functions. The zeros of polynomial function and the coefficients of the function are related. Consider the polynomial function f of x equals quantity x plus 2 times quantity x minus 1 times quantity x plus 3. A, identify the zeros of the polynomial function. Well, in order to identify the zeros, what we're going to do is use something called the zero factor theorem. If we set this function equal to 0, the zero factor theorem really boils down to anything times 0 equals 0. So we know for f of x equals 0, it could happen one of three ways. X plus 2 can equal 0, which is one of the factors. X minus 1 can equal 0. And finally, x plus 3 can equal 0. And what we can do is solve each of these for x. So the first one, we subtract 2. We get x is equal to negative 2. And then for this next equation, adding 1 to both sides, we have x is equal to 1. And the last one, x plus 3 equals 0. We subtract 3, we get x is equal to negative 3. So identify the zeros. Well, the zeros are going to be x is equal to, I'm going to go ahead and write these in set notation, negative 3, negative 2, and 1. So these are the zeros or x-intercepts. And now part B, multiply the factors to write the function in standard form. Well, to do that, we're going to multiply these together, and I'm going to do something we've done in class. Set these up in a box. I'm just going to multiply two of the factors together at first using this box. So we have, I'm going to multiply the first two together first. So we have x plus 2, and we have x minus 1. And so we have x times x is x squared, x times 2 is 2x, x times negative 1 is negative x, and then negative 1 times 2 is negative 2. So for this, we get x squared, combining like terms, negative x plus 2x. That's going to be plus x, and then minus 2. So those are multiplying two of those factors together. Let's multiply the third factor in there. And I'm going to just write this out, make our box a little bigger. Okay, so I'm going to do a 3 by 2. So here we go. I'm going to write this quadratic trinomial. We determine, so I have x squared plus x minus 2. And multiply on the left side here by our remaining unmultiplied factor, x plus 3. So you have x squared times x, which is x cubed. X times x, x squared. X times 2, which is negative 2x. And then 3 times x squared will be 3x squared. And 3 times x is going to be 3x. And 3 times negative 2 is negative 6. And we can combine these like terms in this manner. So I'm encircling the like terms here. So our answer here is going to be, the function of standard form is going to be f of x is equal to x cubed, And we have 3x squared plus x squared, so that's going to be plus 4x squared. And then we have 3x minus 2x will be plus x. And finally, minus 6. And we could test this by graphing the original factored form or intercept form of the function and the standard form that we determined. 3. How are the zeros of f of x related to the standard form of the function? Well, look at this last term, this constant term, negative 6. Okay, and look at all these zeros. We have negative 2, 1, and negative 3. So these zeros are related to each of the zeros is a factor of a polynomial function is found from a factor or can be found from a factor of the constant term. So each zero can be found, let's say it this way, by factoring the constant term, negative 6. Got a pen that's a little bit glitchy today. I don't know what the deal is there. Okay. Let's go ahead to consider polynomial function. D, identify the zeros of this function. Same manner as the other one. Not a lot of room here, but I'm going to set each of these factors equal to 0. So we put 2x plus 3 is equal to 0. We put the other factor, next factor, 4x minus 5 is equal to 0. And then we have 6x minus 1 is equal to 0. And we just solve. We can solve. We have 2x subtracting 3 is equal to negative 3. So x is going to be equal to negative 3 over 2. On this next one, we have, if we add 5 to both sides of this equation, we have 4x is equal to 5. And then dividing by 4, we have x is equal to 5/4. And the last zero we can find, we add 1. So 6x is equal to 1. And then dividing by 6, x is equal to 1/6. Those are zeros. So we get fractional zeros, but they're rational zeros. Next, multiply factors to write in the function in standard form. Well, again, similar to the way we did for that earlier problem. I'm going to, on this one, start from the left. I think it might be more logical that way. So we have 2x plus 3. And then over here we have 4x minus 5. And we just start multiplying these together. And let me see, I think that might be a little bit off the grid there. Let me move this over. Okay. Move this over here. I just got that edge of it. There we go. I think I might have got off of the... Anyway, let's just go ahead and multiply these together. We get 2x times 4x is going to be 8x squared. 3 times 4x could be 12x. Negative 5 times 2x could be negative 10x. And then 3 times negative 5 is negative 15. And then combining like terms, we get 8 x squared, and then negative 10x plus 12x can be plus 2x, and then minus 15. Okay, now I'm going to set up this box here with the 3 by 2, because now we have a quadratic trinomial times a binomial. So here we go. Up on top, I'm going to write 8x squared plus 2x minus 15. And then on the left side, we're going to write the remaining factor, which is 6x minus 1. And now multiplying these together, we have 6x times 8x squared, which could be 48x cubed. And then 6x times 4x is going to be 12x squared. 6x times negative 15 will be, that's a lot. That's going to be, let's see, 3 times 15 is going to be negative 45. So that's going to be negative 90x, right? Okay, next we have negative 1 times 8x squared, so that's going to be negative 8x squared. So basically, negative 1 is changing the sign of what's on top here. So negative 2x, and then we have plus 15. And so we have here is, in standard form, we're going to have f of x is equal to 48x cubed. We have minus 4x squared. We have negative 92x. And finally, we have, okay, I think I got that wrong. It's going to be plus 4x squared, right? Yeah, we'll get that right. Okay, last one we have is plus 15. Okay, how are the zeros related to the standard form of the function? Well, it's going to be kind of hard to see here. And that's why we get into the rational roots theorem. So I'm not going to go. There's a relationship between this last term, which is 15, and the coefficient of the first term, which is 48. But let's go on here to what we call the rational zeros theorem. Sometimes you hear this called the rational roots theorem. Rational roots or rational zeros theorem. And basically, what you have is, it's kind of a complicated way of saying it. When you have, I'm going to just, basically, the possible, I'll put this in my own words, rational zeros are equal to plus or minus factors of constant term over factors of coefficient of first term. Of first term. And we're going to apply the rational roots theorem, and we're going to test also. And here we have this function right here, f(x) equals x cubed plus 2x squared minus 19x minus 20. So the possible rational roots theorem are going to be plus, rational roots using the theorem are going to be plus or minus the factors of our constant. And what are the possible factors of that? Well, 20. What other factors do we have of that? 10, 2, 5, 4, 1. I think that's it, over 1. And so what we have here is our possible rational roots are going to be just as delineated here. Okay, they've delineated for us here what they are. We have plus or minus 20, plus or minus 10, because 10 over 1, plus or minus 2, plus or minus 1. So all these are discovered. And now it says B, test the possible zeros. Use a synthetic division table to organize the work. In this table, the first row represents the coefficients of the polynomial, the first column represents the divisors, and the last column represents the remainder. So basically what they're using is they're getting this column from the term there. And so I don't like to organize it this way. The way it says use synthetic division table, you can test these zeros. And I like to usually start out with the smallest because they're most likely to be accurate. So, and this gets back to section 7.4 when we worked over synthetic division. So to test the zeros, if we test x equals 1 as a potential zero, we can put 1 here, and then our coefficients of our function in standard form, we have 1x cubed, 2x squared, negative 19, x, and we have negative 20. And now we bring down this 1. So we get 1 here. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. And then negative 19 plus 3 is negative 16. And then we have 1 times negative 16 is negative 36. Or negative 16, excuse me. And we get negative 36 down here. So we do not have a remainder of 0. So we know that 1 is not a 0, and so x minus 1 is not a factor of this polynomial function. Next, we're going to try x equals negative 1. And for that, we're going to put negative 1 out here. And kind of leave a little more room down here for visibility. Again, we put 1, 2, negative 19, negative 20. And we do the same process, bring down the 1, 1. 1 times 1 is 1. 1 times negative 1, excuse me, that's negative 1. So we add these, negative 2 plus negative 1 is 1. Negative 1 times 1 is negative 1. We add these together, we get negative 20. Negative 20 times negative 1 is 20. So we get 0. So x equals negative 1 is a 0. And so, since our remainder is 0, so x plus 1 is a factor. So we can rewrite this function as f of x equals quantity x plus 1, and then the quotient down here is this 1 is x squared, 1x squared, plus x and minus 20. And we can factor this x squared plus x minus 20. So we have f of x is equal to quantity x plus 1, and then factoring this x squared plus x minus 20, we have x and x. We know we're going to have plus and minus. We have to get a negative number like a negative 20. And then what two numbers do we multiply together to get negative 20, but add together to get 1? Well, we will have plus 5 and minus 4. So this is going to be our find the rational zeros, make sure. So this is going to be our answer. And if we graph this, we would definitely see that's the case. So really, that's as far as I want to go here. Okay, factor the polynomial. So yeah, so it's just what we had here. They use synthetic division to get testing 4 first. I like to go ahead and start with the smaller numbers just for simplicity, and the arithmetic is a little easier, and just kind of work my way up from there. Okay, so then we're given another problem here, B, but I'm going to stop right here. My voice is giving out too. So good luck, and thanks for viewing.